Alright, here's an example that we're going to solve with a system. And before we dive into the algebra, let's just take a look at the first equation. So there's an x squared and a y, so therefore I know that this is a quadratic equation, so it looks like a parabola when you graph it. And this other one is a line, so it's linear, and then of course when you graph it, it's a line. So parabola opens up because a is positive, so I could have a line go through like that, which would create two solutions. I could have a line go through just at one point like that, which would be one solution, or I could have the line go through something like that, which would have no solution. So I have three different choices here. So let's go ahead and solve this. You can solve it by a variety of methods. It looks like because I have a negative y and a positive y, it looks like I could just add these up, which is elimination. So let's go ahead and do that. So I have an x squared plus an x. So even though those are stacked on top of each other, they're different terms, so that's how you add them. Your y's disappear when you add those, and then 3 plus 3 is 6. And now it looks like a quadratic, and you know 5 different ways to solve a quadratic. You can run it through your program, or you can factor it. I'm going to factor this one. X equals 3. So you set each factor equal to 0, so you get x equals 2, and you get x equals negative 3. So it looks like we have two solutions. Now, we have to go find the y's. This is the part that I was telling you earlier. You have to make sure you match up your x's and your y's. So let's work on the x equals 2 solution. So I need to find my y, and I need to put x equals 2 back into one of these equations. It doesn't really matter which one I'm going to put it in, so let's just pick the second one. It looks a little easier. So 2 plus y equals 3. So I subtract 2 from each side, so I see that y's got to be 1. So there's my first ordered pair, 2, 1. And then let's take the other one, the other x equals negative 3, and solve for y. So we have negative 3 plus y equals 3. We add 3 to both sides. We get y equals 6. There's my second solution, negative 3, 6. So there's two solutions to this problem. And see how it's really important that I match them up and make an ordered pair and not just have a list of x's and a list of y's, because they do go together very specifically here.